folks. And so we just talked about some very interesting novel use cases that this technology can enable, from, privacy preserving credentials, things like DIDs or verifiable credentials that might be required in order to access, for example, peer-to-peer decentralized, but regulated in KYC liquidity pools, for example, right? Which probably will expand the pie actually, right? Like or not. So what I'd like to talk about briefly here is, instead of I want to talk about the future and where we're headed, but let's talk about what are some of the limitations of legacy blockchains today, and what does Move bring to the table to enable these new capabilities?
I can start, Aniket, if you want, and then I can give you a pass here, right? Okay, cool. So as you know, I've been involved in 3 blockchains, and at least I broke a couple of smart contracts in the past. And I know for sure what was one of the mistakes that we did and what are the lessons learned down the road. The first thing is, many of the primitives originally, especially on the very early days of Ethereum, were just a signature verification and a hash function. And then for more complex applications, you had to rely on some developers, writing on Solidity and now in Move, but I will explain what tricks we did in Move to accommodate this. They had to implement their own algorithms in a very constrained programming environment, because you have to pay gas for all of these things. Sometimes you might not optimize it specifically for the smart contract language. And what we did in Move is we got some of the most interesting primitives and we put it as L1 supported natively functionality. And this is very important, because even now in Ethereum, you have to rely in some particular cases in third parties just to have zero knowledge proofs, right? And because, people are not familiar with all of the complexity that this entails, right? And what we did is we enabled a zero knowledge proof verifier in Move. So we have Growth 16 and people can now do Growth 16. And in the future, we made it agile enough so people can come and bring more functionality into the verification stage. Typically on the blockchain, what do you need, right? You need verification. All of the signing, proving, sometimes even the extraction of randomness is happening off-chain. But what you need to actually include as functionality internally is a very simple API for these things to be verified, right? This is what you want. And typically it's deterministic function. And that's why we don't have secrets on the blockchain, flowing secret, which means that you don't literally sign in a smart contract. You sign off-chain and you send the signature as a verification on the blockchain. And now that I mentioned signatures, then I realized, we have all of these systems that, typical in the past, they only support one signature algorithm. And then if you go and see what the banking sector is using, like some old HSMs, or what are the mobile devices using internally in the secure enclave, they use ECDSA still. And they sometimes use not the K1 curve that is used on the Bitcoin, but they're using the NIST curve, like the one blessed by the agency of the United States, right? And then what we did is crypto agility there. We allowed 3 signatures that we believe are the most common in the space to have compatibility with everything. The ECDSA K1, so a Bitcoin or an Ethereum developer, along with support of Ketzak hash function, they can literally have Ethereum signatures being verified in Sui. So we took into account bridging as well. And bridging is very important, right? Because if you know Sui Move has the support, Supra oracles can probably be a bridging provider in the future by having easier creating a system that can verify this kind of signatures both in Ethereum and in Sui, and they don't have every single time to reinvent the wheel and implement a new signature algorithm. At the same time, it gives the ability to people to create new multi-sig schemes where someone might say, okay, I will use a mnemonic, but at the same time, I want my iPhone literally on the secure enclave to sign a transaction. I don't even know the secret there as a 2FA. So allowing a larger set than previously of signature schemes enables Sui some agility and some new perspective of how you can do authorization of transactions or even bridging functionality from other blockchains that wasn't the case before. Now to do some bridging, you have to go through other systems like IPC or like Cosmos and other situations. While in Sui, we have this embedded into the the protocol, BL1. The other thing is we allowed BLS verification. And I know that BLS is also very important for you, right? For Oracle, for Super Oracle, pretty much all of the Oracle system, because BLS is a very, very a useful system due to aggregation. Eventually, we're ending up into like a very compressed output. And now someone can use it not only for signature verification, they can even use it for randomness verification. They can even use it for timed release verification, for identity-based encryption verification. So by allowing extra primitives that you didn't have before, we believe that in Sui it's easier for the average developer to just go and say zero knowledge proof.verify. Supra Oracle's random beacon.verify. Right? You don't need to actually implement all of the functionality to be supporting all of the other features that are existing in other blockchains as third-party development. So we're working into this stuff, so we have as much as cryptability as possible. We even support ECVRF, for example, in Move, and you can even see like bulletproof scamming and some other systems like are next to the door at the moment. And yeah, I mean, you have also experience in other blockchains, and you can even tell us, right? I mean, Aniket, if you want something to exist on Sui, let me know, right? What do you want to have here?
Yeah, and so indeed, I guess let me start from that point. Indeed, the capabilities that are incorporated in Move, especially with the Sui, are quite tremendous. In fact, let me start with a bit controversial, funny statement. Maybe with all these capabilities available, the idea that you're taking away the jobs, taking jobs away from cryptographers, from the traditional system. And let me elaborate that from an example in a way, right? The idea is that let's say I build a current solution which involves some cryptography today in a traditional blockchain environment. There, the key thing is always ability to get some property in system of Bitcoin, and the gas cost and latency of something like Ethereum and other systems like that. And what can happen that tomorrow with a minor update, somebody might be able to make it a bit more better, or more importantly, more gas efficient, and you're stuck. You'll all of a sudden, that's what matters. But and that certainly, it actually in a way facilitated good research perspective to bring a specialized smart contract which can make it work tailored. Like, oh, this operation costs this much gas and this other operation this much cost, so I'll try to combine them in a fashion to save the gas. But they are artificial in a way because those are the gas costs that are decided on the system, and it's not that I can take that exact same solution and make it work elsewhere. On another system, it will be completely different ball game, and a solution in one system may not remain applicable in another system, and I have to start from scratch. So I have my job. Coming back to Joe. However, if you have capabilities like that are inherently available by blockchain level itself, then it becomes much more easy. You are much less vulnerable for the easily getting scooped by somebody who just make some delta modification, because all these things are there and also cost effective, cheap, and also at the same time there is no latency issue in most environments. So that do make all these things very easy, where you build something where development is easy, because you don't need, as long as you understand the input and output behavior of such system, you can build your protocol efficiently without worrying about cryptographic knowledge or having cryptographic capabilities. So that is a huge tool and extremely important thing to work, because many environment, even today, when we try to work, like let's say, just to give example, scriptless script, if people in the audience has heard about in the Bitcoin context, they're interesting technically. It's a very interesting thing. It's nice for us to work on the black, but to implement those is a significant challenge, because there could be significant off-chain component to ensure the security. What on-chain cryptography can allow is to make these things easy and less error prone, because now everything is already worked upon. So that I certainly see as a really important direction that will emerge as more and more cryptography is available. And actually, I want to add, indeed, because is adding those many options there, that will also force even others to consider that, and which is an extremely huge win, because that will indeed make many things solvable directly at layer 1. And if we have efficient layer 1, why to even go for layer 2? So that makes everything very easy. So building application can become easy and also less error prone. So that you don't need to go through hundreds of audits, like you require a special audit for smart contract, special cryptographic protocol, another for distributed system protocol, and maybe fourth one for game theoretic aspect. So all those things become extremely difficult. You may be saving significant time and energy as well as cost by having on-chain access to all sort of different things.
And I will add, Aniket, that a tendency that I personally see is when you provide like to the developers some like a rich cryptographic API, they typically try to build even something that was not possible in other blockchains. Because if you have the primitives and you spend your time, as you said, less on introducing this primitive into the blockchain, now imagine automatically as like an individual, you believe this is a piece of a puzzle, and then you can go and build a bigger puzzle, like a more complex solution that previously you had to implement all of the primitives for this complex solution, combine them like this composability thing that Sui is also offering, which is super useful, right? You can even have an auction like contract, and then along with the composability of Sui plus the primitives of cryptography, you can extend the auction like contract into something else now. And this gives all of this like clarity, because we're a strict type as well. It's not like Ethereum, a random like U256 number. It's an object ID and you can see the type, right? And along with this, plus cryptography, I believe, and I see it already, that some people are building more complex construction that previously was not able to be done either for gas cost, because now all of the primitives are optimized, right? While if you do by yourself, and especially in a new language like Move, people wouldn't be so writing optimized code. And we did it for them to increase the adoption of like a new language into the like the system.
That's great. Yeah. So, traditional blockchains are kind of like, they only kind of speak one language, right? But the introduction of this framework allows, and kind of blockchains of the future are going to be almost like multilingual. Like they'll be able to, different signing algorithms are not necessarily compatible, but if you're able to kind of enshrine this from the get-go, it's going to unlock a lot of capabilities.